So really quick to backtrack, an integer, what an integer is a whole number and their opposite. So that means that if you look at a number line like this, if I had 1, the opposite of 1 would be -1 because both of them are 1 unit away from 0. So they're the same distance away from 0. Okay, so opposite numbers are the same distance from 0, but on opposite sides of the number line, or from 0. So if you look at 3, 3 is 3 units from 0. So -3 is its opposite. So if we were to look at some examples, the opposite of -2 would be +2. The opposite of 1/2 is -1/2. The opposite of 4 is -4. The opposite of -6 2/10 is 6 2/10. Okay. Now, 0 pairs. This is actually super, super, super important about what 0 pairs are. Okay. So 0 pairs means what numbers can you add together that zero out? Well, opposites to do that. So when 2 opposite numbers are are added, the result is always 0. These numbers are also called 0 pairs. So -1 plus 1 is 0. Because if you think about it, okay, if you're on a number line, if you add -1 plus +1, that's a 0. Okay. All right. 2 plus -2 is 0. -7 plus 7 is 0. Okay. All right. So now this is also kind of where additive inverses come from. Okay. And a number's additive inverse is the number that when, sorry, just a second, when, the sum always is to 0. All right. So if you think about this, okay, we're not going to worry about this. Additive inverse is basically the same as 0 pair. So which pair of numbers are additive inverses? Well, -3 and 0. If I were to add those together, would it be 0? No, it would be -3. So those aren't additive inverses. 8 and -8. Yes, 8 and -8 are additive inverses because when I add them together, it adds up to 0. Okay, 2 and 1/2. No, because 2 and 1/2 is 2 and 1/2. Okay, all right. So okay, so if you think about these are just basic problems. 10 minus 5 is 5. 5 minus -10, well, if you think about it, here's what this would look like on a number line, right? Here's 0, here's 5, here's -5, here's -10, right? That doesn't matter. So we go up 5, so that's +5. Now we're going to subtract. When we subtract, we're going to go in the dark side. So we're going to subtract 10. All right, -10, and this is where we land. We land on -5. Whoops, sorry. Okay, so this is -5. Okay, 7 minus 3, no brainer, that's 4. What's 3 minus 7? Okay, that would be a -4. So do you guys kind of see what's happening here? Kind of interesting. Okay, 4 plus 5 is 9. -4 minus 5. Well, let's see what that looks like, shall we? Okay, so -4, I always refer to a number line, okay, just because of the fact that this number line, it will help you. So the first one is -4. So it goes down to -4. Now we are subtracting 5 more. So since we're subtracting, we're going to keep going in the dark side. So 1, 2, 3, 4, 5. We land on this, which is -9. Okay, so -4 minus 5 is actually a negative 9. 9 plus 2 is 11. Negative 9 minus 2 is a negative 11. All right, so we'll talk about that here in a minute. All right. Well, let's go back to our notes. We're going to head back to our notes right now. So everybody grab out your notes, your notebook. Here's what we talked about so far. Okay. Today we are subtracting integers, right? And what I did is on a number line, I showed you that if you had 5 minus 3, we went up positive 5. Then since we're subtracting, we turn and go into the left side 3 times. We also know, since we added integers yesterday, that that's the exact same as 5 plus negative 3. So I'm just going to get right to the rule right now. I mean, we could spend a lot of time going over this, but I'm just going to tell you what the rule is for subtracting integers. Okay, you ready for this? Okay. La, 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 la. Here it is. Actually, you know what? You know what? We're going to pause for a quick second. All right. And I'm going to put you guys in a really fast breakout rooms. And I want you guys to come up with a rule. For subtracting integers. So like if I had 14 minus 32, okay, write that down, 14 minus 32. How would you solve this? So today I'm going to ask you guys, when you guys get into your breakout rooms, I'm going to ask you guys to go ahead, pick a spokesperson that's going to share what your group talked about. Okay. All right. Okay. So when you get a problem like this, the very first thing that I want you to do is I want you to walk through this and I want you to change this subtraction sign right here into an addition sign. So it's going to look like this. We have 14. There's 14. It's still 14. We're going to change this subtraction to addition. So I'm going to make this change first. Now, there's a consequence. You can't just be going around changing subtraction to addition without a consequence. The consequence is that the next number turns into its opposite. All right, so this number is 32. Okay, don't let this subtraction sign get you confused because we already made that change. This number is 32. So the opposite of 32 is negative 32. Okay, and now guess what? You're back to solving an addition expression. Okay, now solve the addition expression. Okay. Now I know some of you guys are like, Mrs. Parkin, can't we just do da 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 da? And I'll tell you why you have to do this in just a second. Okay. Because I would like to teach you my very own song. Here we go. When subtracting integers, here it comes. Are you ready? You've got to keep change. Keep change. Keep change. Keep change. Woohoo! And then I can get even crazy and I can make it country. Keep change. Keep change. And then I can go opera. Keep change. All right. Yeah, you can make keep change any way you want it. Here is what keep change means. Keep change. All right. So let's say you have a problem that looks like this. 20 minus 30. We'll keep it simple, right? So you're going to keep the first number in this expression the same. We're going to MC hammer it. Can't touch it. Can't touch this. Do, 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 do. Can't touch this. So keep the first number the same. Change subtraction to addition. Okay? We're going to change subtraction to addition. Then we're going to change the next number into its opposite. Keep, change, change. Now you guys are back to solving what we learned how to do yesterday. When I have two different sign numbers, I subtract them and I give it the sign of the larger number. So my answer would be -10. Okay, keep, change, change. Keep, change, change. Now, I know some of you guys are saying, well, Mrs. Parkin, that seems like a lot of work just to solve a problem that I think I already know how to solve. First of all, you're not going to want to use a number line for this. All right, number lines are fantabulous. However, when you get to double-digit numbers like this, you're not going to want to think about this on a number line. So you need to have a rule. All right. Okay, so here's why. You guys are going to be getting problems, well, and equations eventually that look like this. You don't need to write this down, just watch. -14 minus 10 plus -12 minus -13 minus 4. Okay, so you guys are going to come across problems like this right here. And I promise you, especially when you get to this right here, you're gonna end up somehow kind of making it all wacky. All right, so if you can change this whole thing to addition, you don't have to worry about subtracting anything anymore. Okay, I promise, I promise, I promise. So let's write down some examples. All right, so the first example I want you guys to write down, we're gonna start simple again. All right, so we're gonna go 12 minus 30. Okay, 12 minus 30. I'm gonna have you guys write 4 problems down right now. The second one I want you to write down is -12 minus 30. Okay. The third one I want you guys to write down is -12 minus -30. And the last one I want you guys to write down is 12 minus -30. All right, so please write those down. Okay, so here we go. By the way, you all did fantastic in the chat room. So what we're going to do is we're going to KCC it. Keep, change, change. Woohoo. Keep, change, change. So we're going to keep the first number the same, change subtraction to addition, and then change 30 into its opposite. Okay? So these two expressions are the same. The only difference is that one is subtraction and one is addition. Now I'm going to refer to what I learned yesterday, and I'm going to solve this. So I'm adding 2 different sign numbers. So I don't add, I subtract. So 30 minus 12 is 18. Then I give it the sign of the bigger number. 30 is bigger than 12. 30 is a negative, so my answer is a -18. Okay, all right, here we go. Show me what you guys got in the chat room for number 2. Rewrite it. All right. right, so you ready? Here we go. Again, we're going to keep, change. So we're going to keep the first number the same. So it's negative 12. So I'm going to keep it as negative 12. Next, I'm going to change subtraction to addition. So I'm going to make that change. And remember, there's a consequence. The consequence is the next number has to turn into its opposite. So negative 12 minus 30 is the same thing as negative 12 plus negative 30. And now I'm just going to add them together. I'm going to go back to the rules that I learned yesterday. When you add two numbers with the same sign, you add them. 12 plus 30 is 42. Both of them are negative, so my answer is a negative 42. Okay, so that's why yesterday it was so important that you understood how to add integers, because that's what we're going to do from now on. Okay, all right. So here we go again. Ready? We're going to keep, change. So keep the first number the same. Change subtraction to addition, and now do the opposite of the next number. Change it to its opposite. The opposite of 30 or negative 30 is positive 30. Now we have a subtraction or an addition expression. So when you add two different sign numbers, you don't add, you subtract them, and then you give it the sign of the bigger number. 30 is bigger than 12, and 30 is positive. So my answer is positive 18. Okay? And last but certainly not least, I'm going to just go through this right now. Keep the first number the same. Change subtraction to addition. Change the negative 30 into its opposite, positive 30. And now look what I get, positive 42. All right, so that is how we don't really subtract in this class. All right, because every time you come across a problem, you're going to change it to addition. And here's why. Like I told you guys, I was helping some algebra kids. All right, this is what they had. Some of the problems look like this. They had negative 2 times x minus 4 minus 3x equals 10. So this was their equation, right? The very first thing I make them do is I make them go through the whole expression, changing all subtraction to addition. So, oh, there's subtraction. So keep, change. That turns that into a negative 4. Oh, there's subtraction. So keep, change. That 3 turns into a negative 3x. So now watch. I distribute. That we already learned. So that would be negative 2 times x. And here's the important piece. If you don't do that, a negative 2 times a negative 4, it's a positive 8. And we're going to talk about multiplication later. All right. And then the rest of it would be negative 3x equals 10. But now the nice thing about doing that is now the fact that you now know what's positive and negative, so that when you add them together, it's going to be much easier to get an accurate answer. Okay. All right. So